So let's continue our conversation on the place value system, which ultimately is meant on developing number sense. And when I say number sense, what I'm really talking about there is where you can take a given number. For example, I could take the number 3,264 and really talk about what exactly is this number. And it can be a lot of different things that we know that this 3, as we look at it, well, what all can 3 be? Well, 3... it represents 3,000. Our 2 represents 200. Our 6 represents 60. And my 4 represents 4 ones. And we can see right there, just by kind of breaking that apart, we see that that's expanded form. And there are other things that we've learned about it. We know that 3,264, if we were rounding to the thousands, where would it fall on that number line of, if, would it be closer to 3,000 or 4,000? So if I were rounding it, we know that because of the 2 tells us that this 1,000, it would be closer here. So once we get into really looking at different numbers, our goal is to not just see the number at a surface level, but to really be able to dig in and to deconstruct that number in a way that allows you, as growing mathematicians, to have a deeper sense of what that number means, because that essentially will help you as you evolve your mathematical skills over the years. So today, and I know when you look at this learning target, it's a very, very, very thick learning target. What I've done is I've honestly taken a couple of learning targets and I've put them together, and the reason is I'm teaching you a skill, not necessarily based on the operation, but based on your understanding of the relationship between place values. So today, after this lesson, along with some practice provided, you should be able to show that when a whole digit number moves a place value position to the left, that it is multiplied by powers of 10, and when a whole digit number moves the place value position to the right, it's divided by powers of 10. And ultimately here, what we're going to be looking at is the same skill, but we're going to see this multiplied, and then we are going to see divided. So we're going to look at really those two operations and what do they really have, how do they impact numbers as we look at them on a place value chart. So it's the same skill, it's just each operation has a different direction. So I don't want you to get overwhelmed when you see this kind of wordier learning target. So that's what we're going to do today. We're going to look at, when we deal with powers of 10, how do the numbers move on the place value chart. So let's go ahead and take a look, and we'll start with multiplication. The first thing I want to do is I'm going to draw a place value chart. Now, for the point of this lesson, I understand that in our conversations in the first 4 learning targets, we've been talking about place value position from the thousands all the way up to the billions. I don't need to draw all that because I don't need those to explain my position. So for this particular, I'm going to, let's see here. I'm going to draw me a place value chart, and we're going to use, let's see here. We'll just go with the ones, tens, hundreds, thousands, and I'll even go 10,000s here. So that's my place value chart. Now, first thing I want you to know is that, and I'm going to step aside over here just for a second. So I'm going to kind of come over here, and I'm going to talk about ones, okay? So I'm going to come over here and say, let's talk about the ones. I know that the ones have a relationship to the tens, okay? So for every 10, this tally mark means 110. Okay, for every 10, that means I have to have 10 ones, right? So that means that we can establish that the tens place is 10 times greater than the ones, correct? So I know that the 10 is greater than the 1. By how much? Times 10. Now, likewise, if I were to compare the hundreds and the tens, okay? So this will be my hundreds, okay? Now, for every 1/100, how many tens would there be? Well, there'll be one, and let me even stop us here, and we'll just skip counting out. Ready? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So we see the same relationship. For every 10 tens, there are 100. So the first thing I want to kind of point out, and let me, just so that we don't get too cluttered here, I'm going to get rid of this little chart here, and I'll come back to it, and I just want to illustrate it in a way that makes a little more sense. Each place value over, this is 10 times, okay? The tens place is 10 times greater than the 1. So if I come over, it's 10, meaning, let's take a look at this. I have the number 3. Well, what is 3 times 10? Meaning that if I have 1, 2, 3, okay? If I were to have 10 of those, so that's 2, 3, 4, 5, 6, 7, 8, 9, 10. Now let me count them, make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what I know then is if I have 3 and I multiply it by 10, I get 30. Now I know this isn't complex math, and I know you're thinking, where are you getting here? But what I want to show you, and one of the big arguments, and I will go ahead and tell you, the way I learned, and more than likely the way your parents learned, is that we learned this little trick where any number times a number with 10, and we'll call it powers of 10, and we'll get into that really in our next lesson. But any number times that, I simply add a 0. So I could take a number like 3 times 10, and that the strategy, the trick, is simply, add a 0. Same thing, I could take the number 231 times 100, and the strategy we were taught was 2 zeros, so just take the original number and add 2 zeros. But what I want to do is teach you the concept, not the strategy. Now let me come back to that. That strategy does work, but it's the skill behind it that I want to drive at you. What mathematically is going on, and let me erase this, okay, and draw our attention back here just for a second. So let's kind of zoom in here, and we're going to take a look at this. What happens is when I multiply 3, and this is my number, when I multiply 3 by 10, the number is moving. Any number multiplied by a power of 10, which 10 is, the digit moves to the left, okay? How many places? Well, for each 0, it moves 1 place. So there's 1 0 there, which means it moves 1 place over. So all of a sudden, I went from having 3 1s to 3 10s. Now, any number, any vacancy, that is left open to the left of the decimal, because technically there's a decimal there, then I fill that in with a 0. So therefore, I know that 3 times 10, what happened is I didn't just add a 0, but that 3 moved 1 place to the left to the 10th place. So let's think about this, and let me show you this with a bigger number, okay? So I'm going to get you thinking here a little bit. So, okay. So what if I have this number here? 205, okay? And we're going to multiply it by 100. So let's come down here and write the problem. 205 times 100. Now what is going on here is that the 100 tells me that we see the 2 zeros, and I know that, now watch this, each place over is times 10 greater. The tens place is 10 times greater than the ones place. The hundreds place is 10 times greater than the ones place, which means that the hundreds place is 100 times greater than the ones place. You say, well, how'd you get that? Well, then take these together. 10 Let these two come down here. 10 times 10 equals 100. So, but what I want you to see is how are these numbers moving. And again, the old school thinking was, well, the numbers don't move, just really we're adding zeros or the decimals move. So watch, if it moves 100, so each digit moves 2 places when the multiplication here, this multiplication tells me right, okay? And then the number of zeros here tell me the number of places. That's what I'm looking for. Multiplication will tell me, hey, you need to go. Look at me. I'm so wrong here. I'm already thinking about division. Multiplication means left. The number moves to the left, and the number of zeros tell me how many places. So, watch. The 2 must move 1 place, 2 place. The 2 goes from the hundreds to the 10,000s. And then, honestly, you don't need to count each one. Rewrite the original number, 2, 0, 5, and then fill in zeros past that. So I know that 205 times 10 would equal 20,500. And so that's how those digits move. So let me show you one more way before I get way too long-winded here. And I just want to, I'll erase all this. Okay. One of the things that I want you to do is then, so in that rationale, let's talk about comparing numbers. What if I have this number? 52,254. So what if I asked you then, let's talk about the 5 in the 10,000s place and the 5 in the 10th place. Now be mindful, what I'm about to walk you through, it can only happen in a number that has the same digits in the place value. Like I couldn't compare right now the 5 and the 4 and the 1s, okay? So it'll be like numbers. But if I were to say, hey, what's the relationship between the 5 and the 10,000 and the 5 in the 10th place? Well, there's 2 things that I know here. The first thing I know is that the 5 in the 10,000s place is, okay, blank the 5 in the, and I'm just going to do capital T, in the 10th place, okay? So this can go one, this one only can go one way, okay? How much larger is it? Now here's where you got to kind of come and count. Go with it. H1 is times 10. That's times 10 times 10 and times 10. So it's 1,000. I know that the 5 in the 10,000s place is 10. I'm sorry, not 10,000. See me? Getting a little carried away. All these colors, they make me happy. Is 1,000 times the value of the 5 in the 10th place. Meaning, if I were to break this number apart and say, well, this number is 50,000, right? Plus 2,000 plus 200 plus 50 plus 4. That's the expanded form. I am comparing the 50 and the 5. And I know that 50 and 50,000 is what I'm comparing. If I multiply 50 times this, it would equal 50,000. Because the 5 in the 10,000s place is 1,000 times the size, or times the value of the 5 in the 10th place. Now I could flip that as well, and I'll show you that when we look at division, okay? So let's quickly, we're going to hop over, and we'll look at division, and we'll really, let me just set that same type of, because it's really not going to change much, okay? So let me draw us out a quick place value chart. This one here, nothing really different. The only thing is, what I'd like to do here, I want to put the tenth ones. So I got a big decimal here. Tens, hundreds, just so we can see, well, how does the decimal impact? Okay. So same story here is what if I take a number like this, 15? Well, what is 15 divided by 10? Now with division, we've got some new rules here. Division tells me that the digit is going to move to the right. Okay? Same story with this. Count the zeros, and that's going to be the number of places it moves. Okay? So with division, which way are we moving? We're moving to the right. How many places? Well, we'll look at the zero. So I can quickly, by using a place value chart, solve this. 15 divided by 10 is, I know each digit moves to the right, or how many places? 1. So I could move my 1, it goes one place over here. Well, the 5 also goes one place over here. Now, does my decimal move? No. It stays the same. So 15 divided by 10 would be 1 5/10. Now, one of the big arguments you're going to see is, well, a lot of people say, well, all you do is you move the decimal. And I need you to understand, and in class I'll be able to explain this a little better, is that the digits move, the place values don't move. The decimal doesn't move. Now, is there a strategy where you could come over here and say, well, 15 divided by 10, all I do is, in the 15, I know there's a decimal there. I just don't write it. And so then I can take that decimal and move it one place to the left, and that's how I got my answer. Is that a good strategy? Yes, absolutely. But mathematically, when you went to explain that number, or explain that equation, the best explanation is that the digits moved, the decimal did not move. The decimal, the place values, everything in that nature is concrete. It does not move. So we want to make sure that we understand that. Now when we look at, let's take a look real quickly at one more. Okay, I'll just get rid of this. Okay, and we'll look likewise. I want to show you a similar one to where 5, 2, 2, 5. So what if, again, we're talking about comparing, and like if we were to break this into expanded form, now what if I asked you to compare the 5s in the hundreds and the tenths place? But this time, the last time with multiplication, I chose the bigger one first. But what if I said, well, the tenth is, we'll say blank to the 100. Okay? So, again, both have 5s, but the tenth, what is its relationship to the 100? Well, when you go right, it's a similar thing. Now, there's two ways we can look at it, okay? And I'll show you you're dividing by 10, okay? Every time we go down, we're dividing by 10, which we've seen in our operation. But the opposite of dividing by 10 is also multiplying by 1/10. Throughout this year, I will genuinely push that relationship between the multiplication and division. But you're multiplying by 1/10. So I could say it like this. I could say that the 10th is 1,000ths of the hundreds. Or I could say it's 1,000 times less than. Either one, but you're flipping it over. So this here would be where you could actually use the fraction right here, or you could simply say 1,000 times less than. So when you're solving these problems, my number one suggestion will be to create a place value chart and understand that relationship between them. But remember, for every place value that you move to the left, you are multiplying by 10. So times 10 times 10 times 10 be able to put those together to make them times 100, times 1,000, and so forth. And when you move the number or the digit to the right, you are dividing, but it's still by powers of 10. So that's our look at patterns found within a number. Good luck with your practice activities, and thanks for watching.